I'm Tanya Harrison, and I am the Director of Science Strategy at Planet's federal arm. And today I'm going to be talking to you about access to Planet's high spatial and temporal resolution Earth observation imagery via the NASA Commercial Smallsat Data Acquisition Program, or CSDA. For those that aren't familiar with Planet, Planet is an Earth observing satellite and imagery company whose mission is to image the whole world every day to make change visible, accessible, and actionable. And we do this through two satellite constellations, the Doves and the SkySats. We're probably most well known for our Doves. These are 3U CubeSats that orbit in a 98-degree sun-synchronous orbit, and they all kind of orbit in a line and act like a big line scanner, imaging the landmass of the Earth as the Earth rotates beneath it. These are always on, and so they're just constantly imaging in the background passively at 3 to 5 meter resolution, anywhere from 4 bands to 8 bands, depending on which generation of satellite you're looking at. Then we have a set of 21 SkySat satellites, and these are about the size of a dishwasher. These are more traditional tasking satellites that image at 50 centimeter resolution in RGB, near-infrared, and panchromatic bands. 15 of them are in a 98-degree sun-synchronous orbit, just like the Dove satellites, and then the rest of them are in a 53-degree inclined orbit to get higher revisit rates at the lower latitudes. These are the comparative specs of all of our constellations. We also used to operate the RapidEye constellation, but these reached the end of their operational lifespan back at the end of 2019. And so we've been deorbiting them, but we do have access to all of their archive imagery, and this is still available through our website. We're not going to talk about the SkySats much just because SkySat access isn't included in the NASA CSDA program. So if you want to learn more about SkySat, feel free to reach out to me. My email address will show up later in the slides, or go to our website, planet.com, and you can read more about the SkySats. But the satellites that we're most well known for are the Doves, and all of the generations of Doves collectively are referred to as the PlanetScope constellation. We've had 15 different builds of the Doves over the last 7 years. We are just continuously iterating on them to make sure that we have the latest and greatest in terms of technology and software that's on board. And we try to leverage a lot of R&D from other industries because we're using a lot of commercial off-the-shelf components on these satellites. Just to give you an idea of how much things have changed, by the time we were on build 13 of the Doves, there were no components in common with build 8 of the satellites. This is a history of the Dove payloads. The original goal had been to do 1 payload a year, but over time, the goal became focused on creating a payload that would be better compatible with public missions like Landsat and Sentinel so that people could use all of those data sets together. So we slowly progressed to using larger CCD sensors, using time-delayed integration and motion stabilization, widening the field of view of the telescope, adding compression schemes, improving the spectral quality of the filters, removing stray light, increasing the sensitivity and the sharpness, improving the radiometric calibration, and aligning the design of the spectral bands so that they would be interoperable with other missions that are currently flying like Landsat and Sentinel-2. So we have 3 generations of Doves that are currently operating in the PlanetScope constellation. We have the Dove Classics, or the regular Doves. We have Dove R, which is the Dove Refresh. There's about 25 of those in orbit right now. And then what makes up the majority of the constellation right now are the Super Dove satellites. And all of our launches moving forward at this point are only Super Doves. So initially we had our Dove pilot satellites, which were basically a test of the technology, and these were launched from the International Space Station. There aren't any of these left in orbit anymore. They just had your traditional bare pattern RGB filter in them. Then when we started launching satellites from rockets instead of the space station, we had the Dove Classics, and these are a split sensor where half of it is your typical bare pattern RGB filter, and the other half is a near-infrared filter, so you've got these split frame images that you can see on the right there. Then we switched to the Dove R, where we moved to a butcher block type filter, so the filters go all the way across the sensor with the RGB and near-infrared. And then we have a similar butcher block filter in the Super Dove satellites, but we've added a few bands, which we'll talk about on the next slide. The Dove R and the Super Dove satellites are specifically designed to be interoperable with Sentinel-2. And so you can see a nice plot here in the upper right of how the top of atmosphere reflectance in the different bands for Dove R compares to Sentinel-2. And the results for Super Dove are very similar. In the lower corner here, you can see how the bands of the different generations of the Doves compare to the Sentinel-2 bands. You'll see that in our Dove Classics, the bands were all blue shifted compared to what you see in Sentinel-2. And we've been working to move those bands so that they are more aligned with Sentinel, so that they play more nicely together. And you can see where we've added the spectral bands as well. We've also narrowed the response of each of these bands so that we get better performance in each of them compared to the Dove Classics and even the Dove Rs. So I mentioned the Super Dove is 8 bands. For the Super Doves, we added a second green band, a yellow band, a coastal blue band, and a red edge band. And the red edge we added not only for compatibility with Sentinel-2, but also with the RapidEye satellites, since they had a red edge band for doing a lot of agriculture work. This is an example of some of the Dove R imagery. This is another Dove image over Canada. You'll notice that if you've ever played with any of the Dove Classic imagery, the dynamic range and the sharpness of the Dove R and the Super Dove data is leaps and bounds ahead of Dove Classic. So when you're filtering for images, when you're searching in any of our platforms for the imagery, pay attention to the generation of satellite that you're looking at, especially if you're working in places like the Arctic or deserts that might be sort of washed out areas if you don't have great dynamic range, because the images from the Dove R and the Super Dove satellites will be much better for you to use in terms of the performance there. This is a Super Dove image over Australia, bringing in the near infrared bands. And here's a couple examples of what the temporal cadence gets you. So Planet images the entire landmass of the Earth on a near daily basis to look for change. This is an example over Western Australia in February of this year on February 1st versus February 2nd. So in the span of a single day, you had some huge changes in this area from this bushfire. This is a burn scar in Kazakhstan in April of last year. And this is just the RGB view. This is what it looks like if we bring in the near infrared, so you can see the burned area better. But we can also do a little bit of band math to get a burned area index map. So now we can actually start seeing the severity of the burned areas relative to other burned areas in that same region. So you can do a lot of analysis with this imagery because we have the different spectral bands you can play with. Then we have the RapidEye satellite constellation. As I mentioned before, there were 5 satellites in this constellation that imaged at 6.5 meter resolution in RGB, red edge, and near infrared. As I mentioned, these satellites have been retired, so we're not collecting any new data from them, and they are currently being deorbited, so they will burn up in the atmosphere. But all of the data from 2009 through 2019 is available in our archive. And just for reference, if you want to pause and look at this later, here are the stats for the RapidEye constellation. If you want to really dig into the stats of RapidEye, SkySat, and PlanetScope, if you Google Planet Product Imagery Specifications Guide, the first thing that comes up should be a PDF that gives you all the nitty-gritty technical details of the satellites and the image products that are available. We've had a few programs over the years to get free data access or low-cost data access to the research community. We started with the Science Ambassadors program, which was an application only based on proposing to do cool work with planet imagery. This evolved to include the education and research program for anybody that's affiliated with the university, and we'll talk about that in a minute. And then we've added programs working with NASA, ESA, and DLR. And through all of these programs combined, we have about 1,200 peer-reviewed publications and conference papers that have come out since 2016 when these programs started. I won't go through all of the subject areas, but this is just a sampling listed here on the left and some of the really high impact articles that have come out so far. Basically, if there's any subject area you can think of, there's probably somebody that has done research related to it somewhere with our imagery. You can get a sampling of some of that at planet.com/pulse/publications, or you feel free to reach out to us. We keep a running list of every publication that we can possibly find using Planet imagery. And so we're always happy to share some of those if people are looking for any specific examples. So how do you access this data? Well, the NASA CSDA program provides access to Planet data for all NASA-funded researchers, regardless of what institution you are based at. So you do not need to be a NASA employee. Researchers can be based at NASA, at universities, national labs, or other government institutions like the USGS or NOAA. In the CSDA agreement, you get access to PlanetScope data with a 30-day latency with an initial quota of 5 million square kilometers per user. Now, there are exceptions made on a case-by-case basis to both of these things. So if you need no latency access because you're working on disaster response or something else really timely, like planning your field campaigns or you're in the field, all you need to do is write to NASA and they will approve on a case-by-case basis if they think that you should get a higher quota or no latency access. It also includes access to the entire RapidEye archive. The Planet data products that are not included in this agreement at the time of recording this is that we don't have any SkySat tasking or archive access, and we don't have any access to PlanetScope or SkySat base maps, which are our clearest atmosphere images over a weekly, monthly, quarterly, or annual basis. To apply for the program, just go to planet.com/markets/NASA, and there's a big apply now button there near the top of the page. This will take you to a form on NASA's website that you fill out. And generally in about a week or so, NASA will email you and Planet and let us know if you've been approved for access. And if you have, we'll usually get your account set up within the next day or two. And we'll send you all the login information that you need to get started, some onboarding materials. And if you go to this same website that's on this slide, there's also a lot of training videos that are on there. We also run monthly training seminars near the end of each month, and we have a science newsletter that you can sign up for. You'll automatically be signed up if you register as a user, and this will give you the announcements of what the training topic is for that month, as well as featuring some science that's been done in new papers. So we get a lot of questions about what the usage terms are for the imagery under this program, and we provide the data under a scientific use license. This is not meant to be onerous. We want you to be able to publish anything that you make with the data. So the imagery can be used for the purpose of anything related to science. It just cannot be used for the development of commercial products or services. And through this program, it can't be used for any non-NASA funded work. If you need to do stuff that is not funded by NASA, we have a separate education and research program that I'll talk about in the next couple of slides. You can publish any derivative products in conference presentations, journal publications, media releases, your blog, you name it. This includes maps or figures, anything where you've altered the image in some way. The only thing you can't share are the raw geotiffs that you download from our website. If you take that geotiff, convert it to a JPEG, slap a scale bar on it and a north arrow, that's a derivative product, and you can share that as you like. We ask if you're using it in a publication to please use the citation at the bottom of the page here. This helps us track those publications in the big database where we look for all these things. And if you have places where you can put it in a figure caption saying image copyright year here, Planet Labs, that's also really helpful to us as well. If you're not funded by NASA, we also have this separate global education and research program. And this is available to anybody in the world that is affiliated with the university. So students, faculty, staff, postdocs, you name it. The basic program is free, and it provides access to 5,000 square kilometers of data per month of the PlanetScope imagery. If you need more than that, we do have departmental and campus options available for a fee. These are 15 terabytes and 100 terabytes respectively. Feel free to reach out and ask us if you have any questions if you need more data access for those programs. And if you do use our data for a publication or anything like that through any of these programs, let us know. We love to hear what people are doing with the imagery. If we like it, we might feature it on our blog or in the science newsletter, or even invite you to come to Planet and give a colloquium talk at some point. Right now, they're still virtual, but maybe at some point in the future, we do have in-person colloquia, and the people at the company are always really excited to see what researchers are doing with the data, especially folks like me, because I am a scientist. So I'm living vicariously through all of you. We have a few different ways to download Planet data. I won't go through all of them in detail here just for the sake of time, but basically Planet Explorer is your best bet to get started. This is our graphical user interface that is pretty intuitive. You can click and drag just sort of like Google Maps. You can upload different shape files or KML files or GeoJSON files of your areas of interest and use this to search through imagery. We also have some integrations for common software packages like QGIS and ArcGIS. We also have one for Google Earth Engine that's under development. And then we have some command line interfaces and APIs for folks that are developers or they want to download huge amounts of data. Like if you're downloading thousands of images, the command line interface or the API are the way to go. So I'd like to leave everybody with this challenge at the end of these talks. What would you do if you could see daily change of anything on our planet? If you have any questions about Planet or the satellites or the CSDA program or the ENR program, please feel free to reach out anytime at tanya.harrison@federal.planet.com. Thank you.